Good morning, students. We are continuing chapter number 5, heat. In this chapter, we are studying transfer of heat. In previous video, we have discussed about conduction, that is the mode of transfer of heat. Conduction means it is the process of transfer of heat energy in solids from one molecule to another without the actual movement of the molecules. In today's class, you will be learn about two other modes of transfer of heat, that is convection and radiation. So first topic is convection. Convection is the mode of transfer of heat in fluids wherein the molecules actually move from one part of the fluid to other. Okay, so convection means the mode of transfer of heat in fluids. Fluids means liquids and gases. So transfer of heat energy in fluids is known as convection, where the molecules actually move from one part of the fluid to other. But in conduction, molecule does not move from one part to other. So now tell me, does convection takes place in solids? No, because in solids molecules are tightly packed and they do not move from one part to other. But in convection molecules actually move from one part to other. That's why convection does not take place in solids. Clear? Now let's see an activity.
Today we are going to show the convection in water. Our apparatus are a large round bottom flask, potassium permanganate crystals, a burner, a tripod stand, a spatula and a lighter. Firstly, we are going to fill the flask with tap water. We already filled here. We are going to place it on the tripod stand. Then we are going to add some potassium permanganate crystals. Then we will wait for some time for the potassium permanganate crystals to settle down. And we will place our burner here. Then we will light the burner. And let's see what happens. When the water at the bottom of the flask is heated, it expands. The expanded water is less dense than the surrounding water and therefore starts to rise. In doing so, the cooler regions of the water in the upper part of the flask, being denser, sink. This movement of the liquid, due to a difference in its density, sets up a convection current, as you see in this video.
So you have seen that when beaker is heated, the hot water rises up and cold water moves down to takes its place. That is the convection currents in water. Now we'll study applications of convection currents in air. In nature, sea breeze and land breeze are examples of convection current setup in air in coastal areas. So, what is sea breeze and land breeze? Sea breeze means during the day, the land gets heated quickly and the air above it gets warm. This warm air expands and moves upwards. This warm air expands and moves upwards. Meanwhile, the water takes longer time to heat up, and the air above the sea remains relatively cool. And this cool air above the sea surface moves towards the land to fill the space emptied by the warm air. This flow of cool air from sea towards the land is called sea bridge. Okay, now land bridge. At night, the land cools quickly, but the sea takes more time to cool and remains hot. So the air above the land is cooler than the air above the sea, and the warm air above the sea surface rises up, and the cool air above the land surface moves towards the sea to fill the space emptied by the warm air. This flow of air from land towards the sea is called land bridge. In general, you can remember it. The flow of cool air from sea towards the land is called sea bridge, and the flow of air from the land towards the sea is called land bridge. Okay, next application. Chimneys are fitted in factories to remove undesirable smoke and fumes. Being hot and thus lighter, these gases rises up and escape through the chimneys. Next application. Ventilators and ventilators are placed high up on the walls of a room. The warm air containing carbon dioxide inside the room rises up, and the cooler fresh air flows in through the ventilators. Next process is radiation. That is another mode of transfer of heat. The transfer of heat from a hot body to cold body directly without heating the space between, and which does not require any medium, is called radiation. So in this mode of transfer of heat, it does not require any medium to transfer heat from hot body to cold. And this is the fastest mode of transfer of heat among all these three, and it travels along a straight line, like the light travels in straight direction. Like that, radiant heat travels along the straight line in the form of waves. Then absorption and reflection of radiant heat. Like light, radiant energy is also incident on a surface or on an object and gets reflected. Okay, radiant energy incident on an object and partly reflected. That means not completely, and partly absorbed depending upon the color of the object. Okay, so when radiant energy incident on an object, let's say your shirt, when radiant energy incident on your shirt and gets reflected, some part of radiant energy gets reflected and some part of radiant energy absorbed by your shirt. Okay, that depends upon the color of your shirts. Dark color object absorbs more heat radiation than light color objects. Like if you wear a white color shirt, it will absorb less amount of heat, less amount of radiant energy. If you wear a black shirt, it will absorb more heat radiation. Now let us see an activity.
Black color objects absorb and lose more radiant heat than a white object. Let us learn through an experiment. Take two metal containers A and B. Paint container A with black color and container B with white. Fill both the containers with equal amount of water. To measure the temperature, fix two thermometers in the containers. Note the thermometer reading. Place the two containers in the sun for about 15 to 20 minutes. Again, note the thermometer readings. You will find that the temperature of water placed in the black container rises more than that of the water in container white. This happens because black object absorbs more radiant heat than a white object. Now place both the containers A and B in the shade. You will observe that the temperature of water in black color container cools down faster. Therefore, we conclude that black colored objects absorbs and radiates heat more as compared to the white object in the same time period.
Next, applications of black and polished surface. So first application, the base of cooking utensils is made black to increase the intake of heat from the flame. Okay, if you see the utensil in your kitchen, the base part, or you can say the outer part of the utensil is made black. Why? Because we have studied the dark colors absorb radiant energy. Okay, so the outer part is made of black to increase the intake of heat from the flame, and the inside of cooking utensil is generally kept shiny because to minimize the loss of heat by radiations. Next application, people prefer wearing white or light color clothes during summer in order to stay cool, and wearing black or dark color clothes is preferred during winter to stay warm. Next, the Thermos Flask. Okay, a Thermos Flask is an appliance used to keep hot liquids hot and cold liquids cold, and it was invented by Sir James Dewar.
Vacuum flask or thermos flask. Thermos flask is used to keep things warm and cold. It consists of a double-walled glass flask having vacuum between the walls, kept inside a metallic case with cork supporters. The outer and inner surfaces of the glass flask are highly silvered. The mouth of the flask is fitted with airtight cork. The vacuum between the two walls of the flask prevent heat transfer by conduction or convection. The silver coating of the walls of the vessel reflects back heat radiations. Thus, heat by radiation can neither enter inside nor go out of the flask. The airtight cork, which is bad conductor of heat, prevents any loss of heat by conduction or convection. Some heat may be transferred by conduction through thin glass walls at the neck and the poorly conducting cork.